Hello, everybody. Welcome to Module 2 on our software development course. I guess I'm going to start by saying last Wednesday, was that our last class? Yeah. That is probably going to be the longest class. I wanted to make sure and try to get through all of that review so we can get to the new material and the fun part. There's still some talking, but it's hopefully a lot of new stuff instead of a repeat of what you saw in SDEV 120. But repetition is important in learning. We learn things by hearing it more than once. We don't hear something one time and remember it forever. Or, well, y'all know how life goes. Sometimes that happens, but usually it's more of a fluke when those things that we hear once and remember forever. Repetition is an important thing. So I want to get all the review in. There's still some talking, but the stuff last week was review from logic in general, and the other talking points are about software development specifically, which is just one place that we can apply logic. The previous one wasn't necessarily a programming course. It just uses programming to get practice applying logic. That's just the easiest place to apply those skills. Is the reason programming shows up there at all. A couple things to go over tonight, some stuff about the language in general, but you'll also have that Python essay to do at some point this semester. So that's the topic on that is history of Python. So we'll just do a real quick pass at it. So for reading examples, there's one thing I wanted to mention. I meant to last week, completely forgot. There is a requirement. Let me get all the names on the list, and then I'll get into it. So there is a requirement on all of the homework that looked like people overlooked the first week. Those who have turned it in already, but we're not even to the due date. And if things ever need resubmitted, like that'll happen a lot, especially near the beginning of the semester. I am way more concerned with correct and quick. So before a bad grade shows up in the grade book, you'll get an email from me listing out all the things to correct and get full points on the assignment. Because I'm more worried about correct. I think this is software development is kind of a valuable skill in our modern world. Everything we do is based around computers these days. So knowing about computers is a very important skill. I'm far more concerned with correct than quick. We're not even to the due date yet, but whenever things happen, like things need resubmitted, it will go off the date of your original submission. So like if you originally turned it in on time and it asks for some corrections and that takes you 4 or 5 days, there's no late penalty, it counts as that original. But if you originally turn it in like 2 days late and then some corrections need made and the other one's like another week later, so it goes off that original submission of 2 days late, not the 9 days late when the final submission came in. So the late penalties will always apply to the original submission date. And I understand things happen in life, so if you let me know ahead of time, I'm pretty laid back and willing to work with those because I understand life can get overwhelming and sometimes we just need a little more time until we run out of time at the end of the semester because everything does kind of end at 11:59 p.m. on December 18th. I can say that for certain, nothing gets accepted after that. And I always draw that as a hard line. Like I've sat down with people afterwards and dug through mountains of VA paperwork trying to find the loophole. Trying to help people find the loophole because they just weren't able to finish the semester. And if it's on VA money, then there's some other issues involved. And the time I'm thinking about, there was an emergency situation. Somebody that had like 5 kids, so class was not a priority for him at that time. His kids were, and then I didn't hear from him until after the semester ended. So he never let me know what was happening or anything. But afterwards, it was too late to do anything except help him dig through the mountains of VA paperwork, hoping we could find a loop, hoping we could figure out what the hardship loophole was. But there's that hard line at the end of the semester. Y'all knew that day before the class even started. Okay, so now onto this first thing. So there's a requirement. Because one of the things that we do a lot when we're developing software is we store our data in variables. And there's a lot of ways we can name our variables. There are only a couple of conditions we start with. Usually it has to start with an underscore or a lowercase, or an underscore or a letter. We can't start with a number, and only certain special characters are allowed, and that varies language to language. So in a classroom, it's just a lot easier to say no special characters. Each language will allow certain special characters in the variables, but it's different special characters. So in the classroom, when we're generalizing things, it's a lot easier just to say avoid special characters. Then we use letters and numbers to mean things to us, maybe some underscores, but there's a lot of ways we can put those together. And there are some conventions. And for those who saw that requirement on there, the week 1 convention, I put it in week 1. I went back and forth many times before I decided on this. From the very first time I taught SDEV 140, I went back and forth for like months. After everything else in the course was planned, it's like, I really don't want to do positional notation in week 1, but it's going to make anything else harder. So hopefully week 1, the programming assignments are smaller and easier. So the really, really messy variable names aren't going to be a problem. But every week there's a different type of variable name. So for module 2 homework, actually, everything will be done in either camel case or juxtaposition. I'm getting ready to pull up the list. But we follow certain conventions just to learn them, because we're learning about software development. So we're going to look at each of the most popular naming conventions for variables every week. And one of them is what's called positional notation. And I'm going to borrow real quick the file name that somebody already submitted the homework real quick. So knowing that you're looking at homework, the name of a file for homework for this class, stop the screen share. If you saw something homework for SDEV 140 fall 2022 and saw that the file was named M1 Q14.py, do you know what that file is without opening it and figuring out what the program does for the homework for this class? The person that named that file is shaking their head. They shook their head no. But that makes sense, right? We know how class is set up. They're broken into modules, and all the homework is questions in our class is questions out of the book. So this probably means module 1, question 14 was assigned. Oh, I think there was a chapter in there as well. Let me add that in there. So M1 chapter, what chapters did we do this week? 2. CH2Q14. Knowing that goes with our course, we can all figure out what that means, right? That's the module 1, chapter 2, question number 14 homework. That's one of our naming conventions for variables. And that's what I asked for the first week, because it's what's known as positional notation. Positional notation. I'll put an asterisk here. That is homework for this class. And knowing where that goes, we're able to figure out what that encoding scheme means, even if somebody else came up with it. And something else, the name does not say what that does. We have to look up question 14 or run the program to see what that does. So same thing for our variables. Most often, in pretty much every naming convention except for positional notation, we give the variable a name that is meaningful for what it is. Employee pay rate, hours worked, sales tax, number of students, meaningful names about the data that variable is holding. But in this case, it's not about the not about anything about the program in the file, it's how this file was used. And we can do the same thing with our variables. So I put an example on there. So make sure you check this every week. And if you'd already turned in your homework, you can resubmit it, because another thing, whenever there's certain requirements on how we format our variables, which notation style we use, we usually don't write that way. Positional notation is really, really hard to deal with. It's even harder to write with. So usually what we do is use the find and replace feature after the code works. Then we hit find and replace and switch to the proper notation. I guess I could have pulled this up ahead of time. Which course are we out this one? So if I go into homework, like module 1 homework, the one that's due at 11:59 p.m. this evening. I guess the first one was just taking a picture, screenshot, make sure Python runs, show the interpreter, and an IDE. Oh, not that one. That was just some extra stuff left in from one of the statewide shells years ago. Okay, so there was this list that in the statewide IB online shell that I started with, there was some paper there that talked about good standards and stuff. So I left that in there, thought it'd be useful information. The important one for us, it's actually a requirement. When I scroll down to the bottom, you'll notice it's 10% of the grade on each homework assignment. So it automatically knocks 10% off the grade, drops you right down to 90. So if there's any other issues, it'll drop you below an A on the assignment. But this link will show the naming conventions we're going to use each week. So module 1's use positional notation, and then the rest of them are easy. So module 2 is juxtaposition. That's the fancy word for putting things next to each other. Kind of like in math class. I'll talk about juxtaposition because we're getting ready to get to an easier one. In a math class, when we have like variables X and Y and all that, we don't write 3 times X. We do that when we're programming. But in math class, we just write 3X. We just put them next to each other and people know what that means. That's juxtaposition. Just put things next to each other. Or in the case of variable naming, we use several words and just shove all the words together. Usually all lowercase, so nothing special to separate them. So like, share my screen. So where's a quick place to type? So if we had like employee rate, we would just put the words right next to each other, just shove them together. That's module 2. That one's a lot easier to work with. And then we'll get into camel case, where we start use uppercase letters to show where the next letter is. And camel case starts with a lowercase letter. I just left the text. Oh, it was still open. So we'd start with a lowercase letter, and then when we get to the next word, we capitalize it. So like rate of pay, spell everything out. And then those capital letters are like the humps on a camel's back.
Can we use the underlines too, or just stick together?
So for camel case, it just sticks together. The underscores usually go with all caps. That's the place where it shows up. But for us, one of the standard conventions for constants, the numbers that aren't going to change, we just put them to a useful word because it makes the code read a lot better. If we have a meaningful word to type that number, to type that instead of just the number every time. This one of the standards is to do that in all capital letters with underscores. The spelling the words out with the underscores is really a subset of juxtaposition. But the guy who wrote Python, when he originally wrote it, that was his preferred way of naming variables, was all lowercase, just jammed together. So we still see that in Python all the time. So using underscores with juxtaposition is sort of it's a subset of that in all lowercase. It's almost standard across a lot of different languages to do our constants that way, all capital letters with the underscore. Pascal case is just like camel case, only the first letter is uppercase as well. Then when we get to the end, and we'll mix them. Module 6, Hungarian notation uses a short prefix. So we'll use, this is most common when there's a graphical user interface. We use multiple things. So like on our GUI, there's something called TXT employee rate for the rate of pay. And then when we get to the back end, we can still use that same name, employee rate, in camel case for the variable. And then employee rate is still available for a method name as well. So we would do like Hungarian notation on the GUI, camel case for the variable, and then Pascal case for a method or a function, depending on which language we're in. The conventions change slightly language to language, but we can keep using that useful word over and over again just because we write it slightly differently. And we don't run out of useful words and have to come up with different things. It makes it really easy to tell at a glance which one's which. So we mix and match them, but in general, we're doing a different one each week. And then module 7 and 8, we're going to mix and match them for what I wrote in here is how we would normally write C# code. It's very similar to Java, except that in Java, we would use camel case for both variables and methods, which a method or a function is a variable. It's just a variable holding instructions instead of holding data like we're used to. Holds a bunch of a variable that holds a bunch of instructions, so we can keep using that the same way we can keep using the same piece of data when we have one integer stored to a variable name. What I wrote here is the convention for C#, which has Hungarian notation on the anything that shows on the graphical user interface. So if the human can see it, it gets Hungarian notation. 2 to 4 letter prefix, kind of saying what it is. So like in the text thing here, TXT stands for text box, like the text input, or LST employee rate. So if we're going to print out a list of everybody's pay rate, put that in the list box, the LST tells us where that goes. Or an important one, which you will see over and over and over again, because this is how Google wants people to do Hungarian. Google has their programmers write with Hungarian notation, and it just uses an M for the prefix. So if we have something like some object called employee, we'll get to object-oriented programming later, but we made a custom data type that's built up of a whole bunch of primitive data types. So we only have we store everything we need, all the data we need in one spot instead of 10 different variables, is the preview on object-oriented programming. If we have that, then Google wants their programmers to use Hungarian notation, and they use M for the prefix for member of the employee class. And since y'all know how big Google is, that's how Google wants their programmers to write stuff. So that's one you will see all over the place. The M it's Hungarian notation, but it's member of that class. So a couple notations, we're going to see a different one each week, so you're familiar with them. Some of the biggest ones. Positional notation can be a mess. That's why I started with this file name, because just about everybody in here probably named your files that way, right? You already used positional notation, just not in a variable. And the key thing is that positional notation, it stores, you encode information about the variable, not about the data the variable is holding. So in the example I put here in the notes, Some long string code that we need something to say what it is. So like 2 letters for the program. So I guess that software development or computer science on those examples. 3-digit for the class. So SDEV 200 is the Java class, and computer science 201 is the equivalent to SDEV 120. That's the starting off point. Then a letter and a digit for the assignment. So I'm guessing that's module 6B would probably be the second assignment in module 6. But notice how it's a variable name. So then there's going to be something stored there. So the next one is 1 letter representing the data type. So S is a string. So in the SDEV 200 class, module 6, assignment B, the second assignment, this would be the second string that gets used. Doesn't really tell us what's stored there, but it tells us how that was used. So there are some very, very useful things for that, places to use that. One of the best is in a team setting. If you're on a huge team developing software, you can encode things like people's initials. Everybody puts their initials and the date they wrote that variable, and then other information. So if anybody on the team has a question, they know who wrote it, when they wrote it, what program it was designed to go in, and information about that. So really useful on teams or for project managers. It's also very useful. Sometimes our software can be get a little complex, and even writing the code that we want to happen is going to be very confusing. Some of y'all saw this afternoon where we're using game engines in the afternoon class on Mondays and Wednesdays, where instead of writing the program directly, because it's going to be complex and take a lot and be very confusing, we write a program that writes the program we want. And positional notation is exceptionally useful there because the software we write is just to write another piece of software itself, which means the computer is going to be naming all the variables. So we need to wait for the computer to name the variables, and it'll find all of those and read, and that way we can make sense of what the computer names it. So we make it up every time. So for week 1, make sure you put your variables in positional notation and make up a code. And since you're just making up the encoding scheme, make sure you put that in the comments so that I know what the encoding scheme is. But think about the file name, because I'm pretty sure just about everybody did something similar to this for their file name. Right? You already use positional notation, just not for variables. So you know what it is, and it's data about like who wrote it, why they wrote it, when they wrote it. Think of a team setting, things that would be useful to your teammates or the project manager. Try to encode that information into that variable name. But it's really, really hard to work with. So we're probably not going to do that when we work with it. So I'm going to do a quick sales tax thing. That's an easy one. So price is going to be input. I need a good prompt. The 1940s gangster style prompt. That'll work. Yes, the boss, he wants to know the price. Like 1940s gangster. I tend to write a lot of input prompts in class examples, so I change that some. It gets doing the nice, clean prompt, polite one gets boring. So have fun with the prompts and stuff in this class. It won't bother me at all. And notice that I did the input first, even though that's giving us a number. This is one that I always like to use as an example. The code in the end has to be a certain order, top to bottom, left to right. But that's probably not the order we think of it in. Right? That's the order the computer needs it in. it works a lot better to bounce around in the order our mind thinks about it in. We have the mouse and the arrows and everything. We can click and put our cursor wherever we want on here. So we can move back and forth, use the arrow keys. And when I do splines like this, I think of the input first and then the casting. But in Python, the casting needs to go first. So take that number and then change it into a float, which if you're going to want to get familiar with your home and end keys on your keyboard. Those are incredibly useful. And that goes to the beginning or end of a line. And before the days of a mouse, we would hold shift to highlight instead of click and drag. And so like turn all of that input into a float. So my mind thinks of the input part first. So I'm going to do that first. And then come out and do the float out front. So I'm not working left or right necessarily. And it's a lot more productive to go in the order you think about it in. But now I can hold shift and push end, and then that highlights the rest of that, all of that stuff. So that when I hit the opening parentheses, Sublime, the Sublime text editor will go ahead and do the closing parentheses around everything that's highlighted. But get familiar with where the home and end key are on your keyboard, because you'll want to use those at some point. And things like highlighting with the shift key, arrows, page up, page down. That's how we keyboard control of what we're doing, because, well, if you just look at it, a typical mouse is only going to have 2 to 6 buttons. But the typical keyboard usually has 80 to 110 buttons. Some get up to around the 130 area. But we have way more buttons on a keyboard. So obviously we have a lot more control with this than we do with this. But it takes a while to learn all of that control. Home and end keys will go a long ways for that stuff. So let me say this text example. P5. And once the text editor knows that it's Python file, it'll change the colors and do all that. Okay, now that Deshaun is here, everybody that asked the question earlier is at least here. So some of y'all may have noticed there was a problem with the textbooks. We haven't been able to access it today. And that is a problem on Pearson's end. People are working on it. It should be fixed soon. I'll talk about that more later. But I was waiting until everybody that asked the question was here before I said that. For some reason, we can't get to it. Okay, so back to this positional notation, because there is a requirement every week of how we write our variables. And the first week, it's a mess to work with that. And the other ones, this same thing applies. So if you just like using camel case, but the weekly requirements are the all caps week, you'll be able to do the same thing as we're doing here for positional notation. We don't want to work in positional notation, it's a mess. But we are familiar with it, like the file naming thing. Everybody already does that quite often. So set up a thing, I'll just set the tax rate. I like to work in camel case, so I'll just start working and do all the work in camel case. Tax rate is 0.07. Total is 1 plus the tax rate times the price. So really that 1 there is like 100%. So 1 plus tax rate, 107% of the price is what our sales tax is, what our total is after tax. There's multiple ways. Some people like to calculate it in steps, but whatever works to get whatever you like to do to get the tax rate in there. You can just find the tax rate of the price and then add that to the initial price. If you remember from math class, the distribution and factoring, the 100% of the price plus the tax rate of the price gives us that total. Different ways we can approach the problem. more than one way to do it. That's one of the big things I disliked about that MindTap textbook, is it forced everybody to write the same algorithm in the same way. A lot of those MindTap assignments would even parse your code and make sure you use the correct variable names that they wanted. And we have lots and lots of freedom when we write our code. So now that we have that, we can print it out. So like print, that's going to be plus our total plus today. Try to stick with that gangster, 1930s gangster style prop, Depression era gangster style prop. But I know how they would make demands, not how they would follow up on them. And then once again, with that working inward from the middle outward, I find that to be a lot more productive, because the first thing I thought about was how to concatenate that together. But now I know that total is a number because we just did math with it. And we can't put math inside a string. We can't concatenate a number, so we need to cast that as a string. So str will turn that number into a string and then wrap it in parentheses. Gives us a nice little program that we can test, right? Actually, I'm not going to do that. Most text editors, we can tie our terminals and stuff directly into it. I'm just going to go to the actual terminal. I'll go to PowerShell and then change directories to where I save that. So here's the example I want to run. So I'm going to do is ask the Python interpreter to run. I'm in the terminal, things are space delimited in the terminal. And I put a name in this, I put a space in the file name, which would cause a problem typing that space in the terminal. So if you put spaces in your file names, remember to wrap it in quote marks. You got to include quotas on there being this space here. When we're in text, example.py, and give it a little prompt. How much is the price? So like $23.45. Get that output message, maybe do some formatting and all that. That's a different thing. We're talking about position notation. It's like, okay, the program works. It's ready to submit, but there is one more step in this class every time. So make sure when you go to all of your homework assignments, except for that very first one, we'll have that link, overview of course naming conventions. And make sure you put your variable names in the correct notation, because that's a big part of software development. We want to know those standard notations so we can have a different one. And this is obviously not an exhaustive list. There are definitely more than 8 ways we can notate our variable. I chose the 8 most common. Positional notation, it's like how you probably named your files. Look at this one on the board. M1CH2Q14.py. If you know that is homework for our SDEV 140 class in fall 2022, you know exactly what's in that file. You might not remember what chapter 14 is. It's not like saying this is a payroll calculator, like the name, or a tax calculator, like the name I gave that file. But there's enough information there. That's positional notation. It's really, really useful when we write software that will write other software, because the computer needs to name variables, and computers kind of have to use positional notation or something at least akin to it in order to name variables when the computer writes code. Or it's really best in the place to think about it for when you're developing the coding scheme. Think about a team. You're in a big, huge team sitting at some office in New York, and everybody's spread out amongst different cubicles, maybe 2 or 3 different floors of the skyscraper, just where they have space available. And the project manager's 6 floors up with a better view and a bigger paycheck and all that stuff. But the team has to work together. So instead of giving our variables useful names, like in this program, this little example I just wrote, like price and tax rate and total, meaningful things, we need to use positional notation that tells the rest of the team who wrote that variable. When did they write it? What was it written for? information like that, things that would be useful for your teammates. Or for the project manager, when he sees it 6 months from now, you can look at those initials and be like, I'm confused here, and go right to that person's cubicle, be like, what were you writing? What is this doing? And get some clarification on it, clean it up, or look at it and be like, oh, there's some redundancies here, and gather up see those people's initials in the positional notation, gather up those team members and have them revamp their code working as one solid group so that it cleans up redundancies and things like that. So maybe think about it that way when you're coming up with your encoding scheme. But we need an encoding scheme. There's several layers to it. So just to throw this in somewhere, along with our normal strings, we can also do doc strings where we use 3 quotation marks instead of 1, either single or double. They're interchangeable in Python. So it's for longer strings. It includes line breaks and things like that. And they're often used as comments. If we need a multi-line comment, it's used as a quick way to make a multi-line comment. But keep in mind, it is not a comment. Comments get ignored, but this is actually a string. So this is going to get loaded in from RAM into the registers, passed through the CPU. So we are using resources with the string. It's not getting ignored like a comment would. So if you have lots and lots and lots of them, it'll start slowing your program eventually. You just need a couple of multi-line comments. That's sort of the standard way to do it. So make a string with 3 quotation marks, and then basically just don't save it anyway. And that allows us to make it more complex strings, big long things, and it includes line breaks and stuff like that. But we need an encoding scheme for our variable naming, the positional notation. So I'll start with 2 symbols. I'm just making this up entirely. 2 symbols for what the program was. So for an example, ours is going to be CX for class example. It could also be HW for homework. FP for final project. Where is this variable being used? That sort of information. Like how most of you all name your homework submission files. It's a very common thing. Then 1, 2, 3, 4, 5, 6 digits for the date. And I will go month, day, year, international style. Software developing is an international thing, so which probably resonates the way the rest of the world does, not the way Americans do. Get prepared for that global world, because the global world's here. It's just might as well write our dates the way the rest of the world does. Oh, whoops. And I did that backwards, didn't I? International style is day, month, year. Yeah, the way the rest of the world writes dates, not Americans. And then initials of programmer. One letter for data type, and a counter for that type. So like I for int, and then as we need more integers, I1, I2, I3, I4. But encoding scheme, information, so it's not the data the variable's holding, it's data about the variable itself. And so now following this, price needs changed. So what I'm gonna do is highlight that. And there's 2 different ones. It's one of the keyboard shortcuts. There's competing standards. The original one was Control H, but Control R was open. So a whole lot of programmers have switched find and replaced to Control R because R wasn't used. That makes more sense. Most people in Spider, it's Control R, and most of your text editors control H, but try them both and see which one does which. Control H was the original, but control R wasn't used in those original standards, and a lot of people thought control R made more sense. So now with our find and replace box, we need to follow this. So the program, this was a class example. So CX, the date is 31/10/22. Initials for me is CSF, but everybody that follows that coding scheme, in a real situation like on a team, everybody would be given that code and would have to think of it. For our homework assignments, you'll want to think of a code, and you can feel free to use the same one on all your programs or come up with a different one on every program just to get some practice with it. One letter for the data type. Price is a float, so F, and this is our first float. I guess there's some wiggle room there. I'm going to go ahead and do F0, do the start at 0. And now we have a replace all button. So just hit replace all, and now all we've done is change the text. Our program still works just like it did before, but we changed that the way that variable was spelled. Tax rate's on there. So again, I like to highlight it first. You can also, obviously you can just type it in the find and replace box. I usually highlight it and then hit, in Sublime, it's control H. For those using Spider, it is control R, as in replace. That one makes a lot more sense. So tax rate needs to follow this convention. But we're still on a class example. It's still October 31st of 2022. It's still me that wrote it. It's still a floating point number. The only thing that's changing here is 1, because this is our second floating point number. But following that convention, the way most of y'all probably already name your homework files. You come up with an encoding scheme that carries information about what class it goes to and all of that. And replace all, and it gets all of it once. So if you have 5,000 lines of code, when you have 5,000 lines of code, it's probably in several files, and then you'll have an extra button in find and replace. So replace all in the current file, or replace all in all the files, all the open files, or all the files in a folder. You'll get more options if it's spread out amongst different files. But this one's a short one, and there's only one open. One more variable. So again, highlight it, control H. Still a class example. Today's still Halloween. It's still me that wrote this. We multiplied 2 floating point numbers together, so we still have a floating point number, but this is the second one. And once again, replace all. And now all of our variables are in position notation. But it would be a mess to try to work with that, right? You don't want to try to type your code in positional notation, but it should still work just like it did. Did I close that? I meant to leave that open. Change to where that's at. And then have the Python interpreter run tags example.py. And anytime we have like a green button in an IDE, or F5 is sort of the most common one, push F5 to run the program. Any other way we have to run a piece of software, when we installed a piece of software and we click on an icon in the starting menu, what that does is run an instruction like this in the background in the terminal. Those buttons, those pictures just pass in this instruction to the background. So what I did here is sort of what really happens anytime we run a program. That's why I like to show it some near the beginning. Oh, something went wrong with that. I was expecting it to work.
Input at the top.
This one?
Yeah, all the way to the right. It's like a variable.
Oh, Okay, yes, good eye. And be careful with replace all. You can also replace them one at a time, keep clicking to them, that's usually a better idea. I wanted to make sure you knew the replace all one was there. Or an easy way to avoid that is make sure you don't use any of the same words in your prompt as make sure your variable names don't show up anywhere else. So now if we hit, come back over here and run that again. And pretty much any terminal or shell, Control-C cancels the current run. So you can say Control-C to end that. All right, there we go. Now we get the regular prompt. Wants to know the price, so 23.45, I think is what I put first time. And we get that same total, so it still runs exactly the same. The end user never looks at the code in the background, right? Only the computer sees that. So whatever we call the variables won't really matter, but positional notation is one of our standards. It's definitely in the list of 8 most popular standard ways to name our variables. A mess to work with, don't work with it, use find and replace after your code runs. But I went back and forth over and over again. It had to go in week 1. Because when we get up to harder programming things, it's going to make harder things that much worse. But that is a requirement and a different notational style to use every week. So make sure you keep up on those. It is 10% of the homework assignment. And so is the bug report. So if you leave off the bug report and don't follow the naming convention, you're already down to a low B on the grade. And those are easy reports. The bug report does not even have to be grammatically correct. Just some notes in the submission comment will be sufficient. Like, yeah, there was a typo on the first run. The second run, fix the typo. On the second run, there was a logic problem with math calculation, and then fix that, and then the program ran right. You wouldn't even need to put that in grammatically correct sentence. I just want you to reflect on it one more time about what went wrong, so that you can avoid those moving forward in the future. That 3-step learning process, right? Preview it, practice it, review it. So one more pass at it, but it does. It also helps if everybody's mentioning the same thing in the bug report, definitely know that's something that should be covered in class. So it's helpful in several ways, and just make sure you check that list on your homework every time. So some people might need to redo if you already submitted that and didn't follow that, you should still have the files around. Just go in there and do the find and replace to change to meet that convention. And just make up some sort of encoding scheme. We do make that up every time. That's one big, we want to study all the different parts of software development, not just sitting down and typing. So I guess find and replace is kind of a big part of using our tool correctly, because part of being a programmer is going to be working in text editing. The rest of our notations are a lot easier. Next week will be the juxtaposition. The big thing there is just to remember not to use any capital letters. Just spell things out thoroughly. Like I think I asked, make sure all your variable names are at least 3 words, so they're very descriptive on the data that they're holding. Back to the descriptive names, and then for juxtaposition, just make sure there's no capital letters. And that one's very popular in Python because when we first started writing Python programming language, first started creating that's how that guy liked to write his variables. So it's still, it's kind of stuck around. So some notes here: developing a piece of software. Programming is about problem solving. That's what we're doing. Programming is problem solving. At least that's the aspect we're studying in this class. Because we use the same programming languages to make every robot lift its arm and do a robotic arm, do this, right? Move this way, down, grab something, or put something in front of me. Make a robotic arm, move forward, go down, grab something, move back up, come over, let it go, repeat the process back forward and down. That's what robots do, right? And just keep doing that process. We would use the same programming language. Python is immensely popular for embedded systems because it's really easy for the human, and it'll control a machine quite fine, a robotic arm quite fine like that. But why would we want a robotic arm to do that? Usually there's a purpose, right? For a robotic arm, that motion I just went through is probably picking things up off one conveyor belt and putting it on a different conveyor belt. It's the end of the drilling conveyor belt, so now it needs to go over to the painting conveyor belt. And a human can be paid to do that, but a human can also be paid to do something much better than grab stuff from one conveyor belt, put it on another one. A mindless machine can do that. So there's a problem that needs solved. So even when we get up to the things, that's pretty much what we always do, the software. There's some sort of need. People need something, and there's something the machines could do better. All the documents, writing documents, much better on a machine than handwritten things. One, you just email the copy to everybody in the company, and then you only have to type it once. You don't have to sit there like the medieval monks and hand copy every single manuscript from the pre-printing press days. Spreadsheets, keeping track of numbers, the ability to edit them, because when we write them all down on paper, editing's a little bit harder. It might have to come back with an eraser or some whiteout or something and change what's written on that paper. But I just mentioned copying it. If there's copies, you need to go back and change that on every single copy written on paper. It's written in a spreadsheet. We can just resend it to everybody that has that spreadsheet. If we didn't just share the spreadsheet to begin with, so as soon as we edit it, everybody gets the updated version. We can send it out and the computer can automatically compare it and be like, oh, there's 3 numbers that are different in the new version. Do you want to replace the old version with the new one? And make comparisons, look through it. Lots of problems that can be solved with it. So that's what we're looking for. And in order to solve problems, is something that I'm going to repeat over and over and over again this semester. 4 constructs. This is what we use to solve problems. Or I think I put it in noun form the other day. Did I write it as nouns the other day? Like sequential with the AL at the end. Okay, so I'll do a different form. I was going to just use sequence this time. So instead of the sequential, which I guess that's not a noun, that's the verb form. Sequential means organize it, put it in order. Sequence is the noun for the order. There's some sort of order we have to address. If there's a problem that needs solved, we have to figure out what order the steps to solve that problem are. To select, or the other day I wrote selection, the noun version, or select is the verb version. We have to, a choice has to be made, or probably a lot of choices have to be made. 3, reiterate, or repeat. I will use those words differently. I mentioned it the other day. Repeat is an exact copy. That's like the robot picking stuff up off one conveyor belt and dropping it on the other conveyor belt. And then doing the exact same thing for the lifespan of that robot. That's all it ever does. Pick things up off one conveyor belt, put it on the other. in the exact same fashion every single time, so it never varies. No variance whatsoever. I will use reiterate to separate a repetition as an exact copy, reiterate as a copy with variance. Repetition with a little bit of variance, like mowing the yard. We have to mow a strip in the yard and then move over and turn around in order to get the next strip mowed and eventually finish mowing the yard. We need that move over and turn around part. Otherwise, we just mow the same strip of the yard forever, and most of the yard would get really, really tall while there's one nice, well-kept strip. And we need a way to invoke other things. And we need a way to leave our sequence. Periodically, we have our sequence figured out, steps we need to take. But sometimes we have to leave our sequence, do some other stuff, and come back to it. That's what we have to do to solve any problem. Those four things, the tools. And in 1957, they made the first programming language that had all four tools built in. And since then, we don't really call it a programming language unless it has tools to address all four of these things. So programming languages are how we tell a computer to solve the particular problem at hand. We'll see those repeatedly. Programming languages have these. So now we have those tools. So if we want to solve a problem with a computer, all we have to do is choose the right language for that problem. Because every language has different strengths and weaknesses. And after the first couple levels in the classroom, it's very, very rare. For the very first couple introduction levels, we don't want to overwhelm. We don't want to overwhelm everybody and be super confusing, so we stick with one language. But after that, it is very, very rare to only use one language at a time, because they all have different strengths and weaknesses. So we mix and match them so that whenever we're doing a different part of a different step in our sequence, we can use the language that particular step is optimized in that language, and then maximize what we do. So there's a lot of mixing and matching, which means there's lots of programming languages out there. So what I want to start off with here is a list of things that will be that I like to look at in a new programming language. It's a short list, it's not all encompassing, but yeah, this is the first 8 things I like to learn in a new programming language. So first 8 things I like to learn as soon as possible in a new language. And to be perfectly honest, I make Space Invaders, the classic game, because it covers these as long as you score high, as long as you track high scores, and when that high score was achieved, the classic game Space Invaders covers it all. And I have done that, so that's what I use to learn a new language. So I don't have to think about the logic at all. I know exactly how to make Space Invaders. All I need is the syntax for a new language. So this is the first things to learn syntax wise. And what I guess my recommendation for the first, what you should really know as soon as possible on any programming language you look at. Obviously, right off the bat, oh yeah, so just my tips. So I guess maybe some background might be in order for that, right? I have been using computers for a long time, far longer than most of y'all have probably have been alive. I would suspect. I've watched computers grow into what they are. An example I often like to use is when I'm helping somebody learn a spreadsheet and they've never used spreadsheets before. In 2022, it always makes me sigh. I'm like, that's got to be so overwhelming. The first time I used a spreadsheet, the columns didn't even go all the way through the alphabet. We only had up to column B in row 16. That's 256 cells. We can do a lot with 256 cells on a spreadsheet. Can't spread them out. We can't spread it out as far as we did with today. But 256 cells on a spreadsheet is quite a bit at a time. Then we just have to put it in pull out the old 8-inch floppy disk and put in a different 8-inch floppy disk for the next 256 cells. Back in those days, spreadsheets didn't do very much. So I've watched spreadsheets grow from almost nothing into what they are today. So I learned all the functions in them as they were created, just 2 or 3 at a time with each new version of Excel as it came out over the years, as opposed to sitting down in 2022 and trying to learn all of it. But yeah, had a computer at home. We got our first computer at home in fall of 1987. And there were some computers at school, so I'd seen them around a little bit. It was very, very rare back then. They got the first home computer in fall of 1987. And in summer of 1988, I'm not sure if I can put an exact date on it, but this was far before y'all's time, and you probably have trouble believing me, but kids used to sit at home by themselves all the time. We used to leave them and walk across town without even bothering to tell our parents first. There were standard rules of like what time dinner was and be home by then. We didn't have to say we were leaving at like 6 and 7-year-olds. I'm not talking about teenagers. Kids would be left at home for hours and hours and hours. And in the summer of 1988, it really was like somebody just flipped a switch and that couldn't happen anymore. But it happened suddenly, so there weren't daycares all over the place and things to do with kids. Or preteens and adolescents and all the different age groups. And basically, it was like nobody under 18 should be at home by themselves. And it came in like flipping a switch. Kids shouldn't be allowed to wander around the stores. I remember the time when going to the store meant that kids would just automatically take off running full speed across the store and be in the toy aisle. And when parents finished shopping, they'd come get their kids from the toy aisle. No adult supervision. That was just the standard. Kids were in the toy aisle. The particular story that changed that, y'all are probably well heard from history. John Walsh from America's Most Wanted, what inspired him to start tracking down criminals. A very sad story, but all the stuff changed suddenly. So summer of 1988, kids couldn't stay at home anymore. I lived in a farming community. I grew up out near Pekin, a farm, actually in South Boston. Some of y'all probably know where that is, in Washington County, out in the middle of nowhere. But we couldn't stay home anymore, and there weren't daycares or places to take kids. So they just kept the school open. They just remodified summer schools. So instead of being there for the people that missed half the semester because they were sick or something, they tried to make summer school fun. Tried to do as much as they could. One of the teachers, I think what everybody's favorite, at least from what I remember, was one of the teachers did stop motion movies. So she brought in a huge collection of nice clay and a stop motion camera, and we'd make videos or go out to the playground and do a bunch of stop motion videos. That was a lot of fun. But the music teacher's husband was a programmer. So to have something to do, he gathered up all of the old Apple IIs that the school had around. Because there was computers at school, so he gathered all those up and showed a bunch of kids how to program. So summer of 1988 is when I first learned to program. Really liked it, kind of took to it well, and was constantly doing stuff on computers, and I really liked doing that. Summer of 1992, by then we weren't farming anymore. And I sat down at the computer and did trial and error and what I remember from years earlier. And graphics were always one of my favorite things. I spent the summer figuring out how to make a video game. And there was no Googling it in summer of 1992. It was me sitting there remembering what I did years earlier and trial and error to make it happen. It's so much easier today. But I've been programming for quite a while. So this is the list of things that I think is the 8 things you want to learn ASAP based off of that years of programming. Obviously gaps in there as well, like 2000 to 2009 or so. I spent a lot of time writing novels. There was a long stretch there, several years where the only thing I did on computer was work on writing novels. I just tried to make sure it was like a job. I sit down and make sure I got at least 35 or 40 hours a week in writing novels. Somebody in some rich guy in Baltimore flipped the bill for it, they put it publishing in the agents. But people don't buy books from authors they've never heard of. So my stuff filled space nicely whenever like the Grishams and Stephen King's ran low. Whenever their books are in low, because people knew those authors. I guess my stuff filled the space nicely. Eventually the contracts just sort of expired, and in total I made like $17 and some change in royalties. So they're not so many copies, but it wasn't zero. I just told you that I made more than zero, but so there wasn't a lot of programming there. I spent as soon as I woke up and until I couldn't stare at a screen anymore. I just spent my time writing novels, science fiction novels. There's some gaps in there, but many years of this has led to like this list. So the first thing is the general syntax, which is probably kind of obvious, right? The variables, keywords. How do we make a variable? What are some of our keywords that we'll need? Special characters. I'll kind of abbreviate it because I think I'm going to run out of room, but keep writing this list this far. So in the C family, the curly brace semicolons. Or in Python, the white space, where does all that fit in? And just the general syntax of the language. Indent the if, like in the if else block in Python, we need to indent. And everybody's seen some Python. If you haven't, that'll make more sense. We started using that in the SDEV 120 class. So those who took SDEV 120 before then, I think a couple of y'all did. I remember some of y'all had me for that class back then. But the white space matters. So white space is a special character. Kind of like when we put when we need a space in our string, we have to actually tell the computer quotas I'm putting the space here and make sure we hit that key inside of the quote marks so the computer knows to type it there. Well, white space matters inside of our code in Python as well. But the general syntax, obviously you want to learn that one first. The second thing is, how do you do collections? In your SDEV 120 class, we're talking about arrays. Even though SDEV 120 doesn't use arrays, it uses lists. Arrays is our catch-all term, kind of like we say Google it instead of search for it, or use a search engine to find it. Especially now, say TiVo or Roku, and somebody says Roku, we know they might not necessarily be talking about the name brand smart TV. Okay. They might have saved $300 and bought an off-brand one, but it's still the smart TV subscription. And we use there's that name brand when it takes off. Array is like that for collection. The one we actually use most often is a list, but that word has a lot of pre-connotations in English. Okay. We use list all the time. I'm writing a list on a board, but it has nothing to do with the computer collection called list. So arrays, lists, stacks, queues, like standing in line queue. The UE is silent. QUE, UE. What else can I put on there? Dictionaries, we'll see that soon. There's lots and lots and lots of them. We'll see a few this semester. We'll definitely see arrays list and talk about the difference between those and dictionaries, and probably talk about stacks, but we'll see different ones. So how do we collect data? So if we have 50 data points, we don't want to sit there and make 50 variables. So how do we put all of those into one variable name? Might be the way to think about it. The third one, selection structures. There's right off of the for constructs, one of our core tools. Need to do that. Sequence is going to be included in the general syntax because when we write lines of code, they run in order. Reiteration. How do we make loops? What do we do if loops not available? Because not all programming languages have loops. What the machine does naturally is recursion, a feedback loop. Everybody's probably familiar with the word feedback from audio feedback. Right? I could make something happen right here in the classroom. If I come over here and do this.
Recording in progress.
No audio feedback.
Turn that back off. Everybody's already familiar with audio feedback. The output from that speaker, or the input, the sound words I was saying went into the microphone, through the whole system, came out this speaker. The sound came out and went right back into the microphone on my computer. And through there, and it output feeds back into the input. That's what we actually have to repeat things naturally for a machine. That's really, really hard to work with. So loops are a high level construct that we're put on top of that to make it easier to work with, but we don't have those in every language. Dates and times. And y'all probably already know the importance of having date and time. We need to know how to do that all over the place. 6, persistent data. We need to be able to save things. I think there's enough room here and still fit on the camera, right? Yeah, it looks like it. 7 is strings. With IoT coming more prevalent, in parentheses, I'm going to put general output, because maybe on an IoT device, a word on the screen isn't our standard output. Our most basic output for a program is going to be a little LED comes on, or a motor moves something. So whatever our most basic type of output is. Traditionally, it's just strings going up, strings of characters, which are special symbols. So a collection, an array, a string is an array of characters. So that's our written language, output to the human. And then the 8th thing, third ASAP, is graphics. How do we handle graphics in that language? Because humans are a very visual species. We want things to look nice. So take note of that list. This is my recommendation on the 8 things you want to learn as soon as possible. And at that point, when you feel comfortable with those 8 things, that's when you're ready to say you know how to program in a particular language. And you don't have to come up with a new way to do it every time. Like I said earlier, I do that with Space Invaders. Space Invaders, a couple layers, and as long as there's a high score that throws in a timestamp, then that whole list is included right there in Space Invaders. And I've done that so many times, I don't have to think about the logic for making Space Invaders. All I need is the syntax for the language. So take note of that list. That's my recommendation on the most important things to do. But at the same time, you've probably heard people say at some point along your way through life, question everything. feel free to argue against that list. If you think there's a better eight things to start to learn as soon as possible, and to get to the point that you can claim you know how to use particular programming language, make your own list. That's the list I've constructed over the years of doing this. But that went 1 minute longer than I meant to. Probably a good time for a break. I was a few minutes and a good pause point. Those things are important. So that's what we need to look at next. That's what we need to look at so we can do this. That's what we have to work with. And more. Programming languages have been building for a while. But should probably take a break before we jump into that part, right? Does 10 minutes sound good to everybody? I see head nods here in the classroom. I assume there's some heads nodding on the Zoom call as well. So my laptop says 7:17, so we'll get back to it at 7:27. We'll see y'all in just a few minutes.